All right, so for lesson 3 of our review unit, we are going to be reminding ourselves of exponent laws. So the first one is what we have our product rule, which is when we are multiplying powers with the same base, we are going to add the exponents together. So in this case, I have x to the power of 5 times x to the power of 2. X is our base, so whenever we look at an exponent, we might get something like this, where x is our base and y is our exponent. But in this case, we're going to keep our base the same, and it will be 5 plus 2, which is x to the power of 7. Reason being is this the same as saying x to the power of 5 is x times x times x times x times x. And this is multiplied by x to the power of 2, which is x times x. And if I add those up, I'll get 1, 2, 3, 4, 5, 6, 7. Sorry, that 6 was supposed to be around this one here. So 1, 2, 3, 4, 5, 6, 7. And that gives me x to the power of 7. So for example, we will get x to the power of m plus n. The quotient rule is when dividing powers with the same base, we're going to subtract the exponents. So, for example, I will get x times x times x times x times x over x times x. If I look, this one and this one will cancel out, and this one and this one will cancel out, which gives me, in this case, x to the 3, which is the same as 5 minus 2. So it would be x m minus n. The power of a power is when you raise a power to a power. When you are doing that, you are going to multiply the exponents. So for example, here I have x to the power of 5, and that is to the power of 2. So what I'm going to do is I'm going to multiply these together, and reason being is that I would get two brackets that are both x times x times x times x times x. There is 5 in there, and x times x. There is 5 in there, so it would be x to the 10. In this case, it will be x to the m times, oh, that's supposed to be an x. X to the m times n. Our zero exponents are any exponent raised to the power of 0 is always equal to 1. It could be 6 to the power of 0 is 1. It could be 7 to the power of 0 is 1. It could be 1,000 to the power of 0 is 1. So x to the power of 0, even if I don't know what x is, I know that it is 1. And the negative exponents is making a fraction with the term in the denominator, and the exponent becomes positive. So in this case, it will be 1 over x squared. In this case, it would be 1 over x to the m. So when we take a look at that, we are going to use exponent rules to simplify these down and then evaluate if possible. So in A, I have my term as x. So I cannot evaluate that unless I know what x is, but I can simplify it down. In this case, it will be x to the 7 minus 3, which is x to the 4. In B, I have x to the 12 plus 2, gives me x to the 14. I don't know what x is, so I cannot evaluate. But in this case over here, I have 3 to the power of 3. And remember, we're going to pretend there's brackets around here. Plus 5, because these are multiplied together, over 3 to the power of 4. So this gives me 3 to the power of 8 over 3 to the power of 4. And then I can 3 to the power of 8 minus 4 is 3 to the power of 4. Now, because I know what my base is, I can do this. And I am just going to type 3 to the power of 4 into my calculator, and I will get 81. And that would be my final answer. So this is my simplification. This is my evaluation. That being said, if you get a question like this on a quiz or a test, you have to show me this step where we simplify it first and then evaluate. Awesome. And one last example here. I have 2a squared b to the 5 times 3a to the 3 b to the 7 divided by a to the 2 and b. When we are doing this, I'm going to multiply these two numbers through the same way you would normally with multiplication. So that would give me 6. A 2 plus 3 gives me 5. B, 5 plus 7 gives me 12 divided by a squared B. So this is like saying there's a 1 in front, but it's not there. So 6 divided by 1 still gives us 6. 5 minus 2 gives us a to the power of 3. And when we don't see a number here, we assume it's 1. Otherwise, the number would not be there. So now it's b to the power of 12 minus 1 gives me 11. And that is my final answer. Now for this one, we are going to use exponent rules for multiplying and dividing powers with different bases. First, we are going to simplify, then evaluate if possible. So when I look here, I'm just going to zoom in on question A. I have two sets of bases. I have 5 to the 12, 5 to the 4. I also have 2 to the 5, 2 to the 7, and 2 to the 3. I cannot intermingle values with different bases, so I have to stick my values together. So I am going to start off with 5 to the 12 plus 4, because these are multiplied, is going to give me 5 to the 16th. That is hard to read, so I'm just going to rewrite that. 5 to the 16. This is going to be times 5 to the 7, which is 2 to the power of 7 plus 5 is 12, over 2 to the 3. My next step is going to be 5 to the 16, and then 12 minus 3 is going to give me 2 to the 9, and now I can evaluate. When I evaluate, if I type in 5 to the power of 16, times 2 to the power of 9. I will get, your calculator might spit this out in scientific notation, but you will get a number that looks kind of like this. If that is the case, that is what my calculator does. All that means is this decimal is actually moved over 13 places. So you essentially just have a really large number. Now on B, I again have two different bases. I have, let me just make this a bit smaller. Oops. X to the 12, X to the 7, and X to the 3. And I have Y to the 5, Y to the 1, and Y to the 2. Now, if we do this all kind of in one step, you will get X to the 12 plus 7 minus 3, and Y to the 5 plus 1 minus 2. That gives me 12 plus 7 minus 3 is X to the 16, and Y to the 5 plus 1 is 6 minus 2 is 4. So that is my final answer. I cannot simplify it down anymore. Now, using the exponent rule for multiplying and dividing powers for expressions with fractions. So again, we are going to treat these how we normally would have fractions. In A, I'm going to simplify this down first because I can see, oops, that the base on all of them is 3/4. So this is going to be equal to 3 over 4, 4 plus 2 plus 1, because we assume that 1 is there. So this is equal to 3 to the 4, 4 plus 2 is 6, plus 1 is 7, and then I can carry my exponent out on both sides. I will get 3 to the power of 7 over 4 to the power of 7, and that will end up being equal to 2,187 on my numerator, and 16,384 on my denominator. The next thing we want to check to make sure is, can we simplify that down at all? And when we are looking at that, first thing I want to look at is 1 is an odd number and 1 is an even number. So I know they're not divisible by 2, but let me just check through, see if they're divisible by something else. And I don't believe they are, so I'm going to leave that at that answer there. Now, when we look on this side, oh, sorry, I'm just going to zoom back out so you can see that for a second. Now we're just moving on to B, where I have 2 over 5 as one base, or sorry, negative 2 over 5 is one base, x and x is another base, and y as another base. So in this case, it's going to be negative 2 over 5 to the power of 6 minus 3, x to the power of 5 minus 1, and y to the power of 1 minus 1. So this will be negative 2 over 5 to the 3, x to the 4, and y to the 0. That turns into 1, and any number times 1 is itself, so we can drop it at this point. And now I'm just going to bring this out to see if I can get that into a more simplified fraction. So negative 2 to the power of 3 is going to give me negative 8. It's an odd number based on here, so we know it's still negative. Over 5 to the power of 3 is 125, x to the 4. And if we take a look, let's just see if 8 over 125 can be simplified. And I don't believe it can. So again, that is our final answer. Now, if you have a power of a product, the outer exponent applies to each factor inside the bracket. What that means is similar to when we looked last at, say, x to the 3, 2. We multiplied that through. This 4 now is going to multiply both of those numbers. So I will actually get x to the power of 2 times 4 is 8. And y to the power of 4 times 3 is 12. This is 2 times 4, and this is 3 times 4. And that is my simplified breakdown of it. If you have a power of a quotient, the outer exponent applies to each term inside the brackets as well. So just like we just did with fractions, this is going to multiply, this is going to multiply, and I will get x to the power of 14 over x to the power of 6, that's 7 times 2, that's 3 times 2. This can simplify down to x to the 14 minus 6, which will give me x to the power of 8. Awesome. And then if we move on to negative exponents, this is another thing, sorry, not negative exponents, but negative values within exponents. This is another thing to keep careful eye on. If the negative is inside brackets, it is included in that exponent rule. If it is not inside brackets with the term, it is not included. So for instance, I know here that 7 to the power of 0 is always 1 based on our exponent rules of 0 exponents. Because this negative is inside the brackets, this would still be 1, because any number to the power of 0 is 1. Now on this side, we can see there's no brackets. So that negative is actually not included in it. So this is the same as saying negative 7 to the power of 0, which is negative 1. Because 7 to the power of 0 is 1, and we're going to take the negative value of that, and negative 1 is our final answer. Another example here, we don't see brackets here. So we assume the brackets are around just the x. So we will end up getting negative x to the 13 minus 13 because of this division gives us negative x to the 0, gives us negative 1 again. Awesome. And the last example that we're going to do is negative exponent examples. So I know if I want to simplify this down, it's going to be 1 over 3 to the power of 2. And this is going to give me 1/9 as my final answer because 3 to the power of 2 is 9. This one here, I'm going to get 1, 3 to the 3rd times 1 over 2 to the 2, which is 1 over 27 times 1 over 4. And now I can multiply these, and I will get 1 over 27 times 4 is 108. I cannot simplify that down anymore. Here, what I'm going to get is my first step will be to simplify it down a bit more. I will get 5 to the negative 6, because that is negative 2 times 3. So this is 1 over 5 to the 6, which gives me 1 over 15,625. Awesome, and that brings us to the end of our lesson. We will have one more lesson in this unit, and then you are good to start on the review for the unit test.